Hello everyone and welcome to this week's video. A few months earlier this year, the OWASP API top 10 was updated. So if you're not familiar what the OWASP top 10 is, it's essentially it's a piece of research really that brings together cybersecurity experts. The OWASP top 10 also had data from places like HackerOne and BugCrowd as well. And they come together and they give you a list of here are the top 10 vulnerabilities you need to care about. And as an offshoot of that, a few years ago, the OWASP API community, which is like a subset of it, decided we're going to write an OWASP API top 10. Really, APIs are just another form of web application, so they're vulnerable to both. But the OWASP API top 10 recognizes that APIs are used in very different situations and therefore have maybe unique security concerns that perhaps aren't shared with other web applications or that aren't necessarily relevant. So today, this is what we're going to be talking about. They just updated the list. There was like a call for consultation. There was discussions on GitHub, and I'm going to present to you about the OWASP top 10. Now, if you're interested in my greater thoughts on these changes, I've actually written a blog post that I'll link in the description that you can have a read of. That's more my opinions. This is the OWASP API top 10. First of all, we have to thank our lovely sponsor, Snyk. There are lots of vulnerabilities out there, like prototype pollution, SQL injection, remote code execution. And while they can be fun to exploit during CTFs, when they're lurking in your code, it's not as fun, and it can be really challenging to find them and remedy them. But that's where our sponsor Snyk comes in. Snyk scans your code, and not just your code, but also dependencies, containers, configs, all in real time, and it finds but also fixes vulnerabilities on the fly. You can actually try it out completely for free using my link, snyk.co/insiderphd. So that's snyk.co/insiderphd. It's on screen, it's in the video description. You can import all your repositories and voila, Snyk will just identify the vulnerabilities ready for you to fix yourself with literally a simple click. It even opens up fix pull requests, so you can actually fit it into your existing workflow, merge the pull requests and get back to doing what you do best, whether that's coding or ethical hacking. Plus, it does all of this using your existing toolkit, your existing IDs, command line, repositories, pipelines, Docker Hub, and more. So it's really low bandwidth on your energy. So check it out and find out if there are any vulnerabilities affecting your projects. It's free forever, so you can sign up using my link, snyk.co/insiderphd. Just says you came from my channel. Thank you very much to Snyk for sponsoring this video. Woo! What does it mean? Mostly the same as the old version. There are some interesting additions and mergers, and I think it's a little bit more helpful to hackers now. Again, I wrote a blog post on my overall thoughts, what I think of these changes. This is more just information. So for each of these vulnerabilities, we're going to talk about what it is, when you as a hacker should be looking for this vulnerability, how you can test and confirm the vulnerability, and where you can learn more, and if there are free labs that you can do to learn more about that vulnerability. So first up is API 1, Broken Object Level Authorization. Now, I made a joke on Twitter that this was the artist formerly known as IDORS, and that is essentially what it is. This is essentially the new name for IDORS. When should you be on the lookout for this vulnerability? If you ever see any IDs or UUIDs, or you're testing a RESTful API, keep this vulnerability in mind. So how does it work? So you have a user and that has a user ID, and maybe they start a post and that has an ID, and you can start to define what that user can do to that particular ID. Because they've made that post, they can read it, they can create new posts, they can delete an existing post or update or delete an existing post. And the same for any other user. Any other user should be able to view, create a new post, erase, delete their post, or edit a post, no matter what, as long as they've made it. And BOLA or IDOR comes into play when we get this cross interaction. So ideally, a user should only really be able to view a post that doesn't belong to them. However, if they are actually able to edit it, that is a vulnerability. So you can imagine it would look like this. If you're logged in as user ID 34 and you do a GET request to that particular post, you should have the view permissions, yep. You should be able to create a new post under your account. Yep. You should be able to delete a post or update a post that, again, you control. So all that should work, and all that will return 200. However, when we start adding cross-user, so where user 32 accesses post ID 20 has been created by the user with the ID of 4. Read should work, because we can read somebody else's post, imagine something like Twitter. We should be able to create a post, because we're not interacting with a specific post, we're just making a post under our account. It's the same as the endpoint above. But we shouldn't be able to update or delete that particular post, because both of them belong to the other user, right? We should get a 401 unauthorized. However, if it does work and we actually get a 200 back, that is a IDOR, that is a bowler. So user 32 can edit post 20 even though user 32 is not its author. It is simply the ability to do some action to a resource that isn't yours. So how do you test for it? So step 1, create 2 accounts, a victim and an attacker. On the victim account, you want to do a lot of different actions, interact with the API a ton. Anything that has an ID number in the request should be like you looking at specifically. Repeat all these requests, but replace the victim's cookie with the attacker cookie. Now, if that request still impacts the victim's account, so the first account you logged into, not the attacker's account, so if it impacts the victim account, so it edits a post that should be owned by the victim, that is a bowler. If it impacts the attacker account, it's not a bowler, because, say for example, creating a new post, if you create a post with another user, you'll just be creating a post under their account. You're not impacting the victim at all. If the ID is a UUID, explore the API to try and find that ID. UUIDs don't actually solve this problem. This access control is still a vulnerability, but it is a mitigation. So if you can find where those IDs are actually generated, or you can find them referenced in another API endpoint, that's really helpful. If you want to learn more, I really recommend OWASP Juice Shop. It's a lab where you have a JavaScript front end and a RESTful API backend. And actually there's a ton of different vulnerabilities in there, but it's really great for kind of picking up API pen testing, even though it's not specifically an API. API 2, Broken Authentication. It's essentially account takeovers. It's the ability to log into somebody else's account. When you're looking for this vulnerability, any app that has a login process, or if it has both like a login with Google or a direct login, both of those can be vulnerable, the OAuth flow and the traditional login flow. There's lots of different ways that you can actually find this vulnerability, looking at password resets, OAuth flows, looking at JWTs or API keys, testing for brute force and rate limiting, testing login flows to see whether or not you can generate a token for an account. Any kind of account takeover here. Account lockouts can be covered. However, it depends whether or not the client will reward that vulnerability. So it essentially covers all the different ways you can log into an account that's not your own. So test for your typical account takeover types. Test password reset functionality, resetting a password for an account you don't own, generating a token for an arbitrary password reset. Test rate limits on the API. Note that IP rotation is typically not rewardable in a bug bounty situation, but if you're in a pen testing situation, you may want to try IP rotation to do an account lockout. Check any JWTs, so see whether or not you can actually edit the JWT or generate a valid JWT for another account. The JWT secret may actually be in the source code. I've seen that before, and they've accidentally committed like the source code, like an SVN or a Git repo that you can see the correct changes in. And then sometimes the system may not check the JWT signature, and therefore you can just edit it and it won't be confirming whether or not you actually need that secret. If you want to learn more about authentication type vulnerabilities, Portswigger's Web Security Academy is really good. Highly recommend it. Super. It's completely free. It's all using Burp, and it's all completely online. You don't need to set up anything on your computer. If you have a lower spec computer, it can be a bit more helpful. API 3, Broken Object Property Level Authorization. This is a new vulnerability that has just entered the OWASP API top 10, and it combines information disclosure with what was previously called mass assignment. So you want to look for this vulnerability wherever you see a property in a response that is not a parameter in the request. So if you make a request and let's say you can do a get and you can find not just the user ID, but maybe like their email or something a bit more personal, maybe like personal data about their account. For the mass assignment, you also want to be testing any kind of input that has like special conditions around it. So things like passwords where you have to confirm your password, that's also where you want to be looking for these. Any kind of API that returns a large amount of information, or any PII in a response that doesn't belong to your account and perhaps you shouldn't be seeing. That can also cover like business logic disclosure as well. So what does this mean? You've got a user, they create a post with the ID of 45, and the post has the following. So how does this work? You've got a user, they make a new post with the ID of 45, and they make a GET request to a RESTful API using /API/post/45. And you can see the properties in there. So it has the ID, the text, the author, a reply to field, and a created at field. Now, if you want to update that, you do a put to /API/post/45. You give it the property and the new value, so changing the text property. But all of these other properties shouldn't necessarily be able to be edited, right? The ID we shouldn't be able to change, the author we shouldn't be able to change, the created at, again, we shouldn't be able to change. However, in a mass assignment type vulnerability, we would be able to update it with the ID, the author, the created at. And when does this come into play? It comes into play when we start to have a look at things like passwords. For you to change your password, you often need your old password first. And then your API will send the password property to the value after you've confirmed your old password. However, you might be able to access that API request directly and therefore be able to change the password despite not confirming your old password on the API side. And the reason why this is difficult to talk about is because it's that merger of like too much information coming out of an API and mass assignment. So how do you test for it? For information disclosure, super simple. Test the API, note any particularly large API responses. Check for any PII or information that just shouldn't be publicly available. It's a lot of common sense. You may also want to look at things that use like regex to find things like telephone numbers or emails. Now, for the mass assignment part of this vulnerability, you want to find parameters with special conditions. So you need to confirm your old password before you can change it. You need to pay for a seat with extra legroom before you can be assigned a seat with extra legroom. Then you want to find the API request for that object after that logic has taken place and try and use and include them as parameters. So if you want to learn more, there is a great OWASP project called Crappy, which is a fake API that you can experiment with and has mass assignment in it. API 4, unrestricted resource consumption. It's essentially DOS. You only really want to be looking for this vulnerability if you're on a pen test, because it's not typically rewardable in a bug bounty context unless you're able to crash the API, like the code running the API itself, not just the web server. But what is it? Imagine you've got a website and you've got a bunch of legitimate requests, And as it grows, you get even more requests and even more people, and that's fine because it scales. But if one of those users decides, well, I'm going to start attacking, and keeps going and does hundreds of requests, the legitimate users down here won't be able to access any resources because it's full. But you know what? Your handy hosting provider will give you more resources. You just need to pay for it. And so you can put a bit in the $5. You might need to go up to the $10. Essentially, one user can use up all the resource. Again, it's a type of denial of service. It's usually out of scope for bug bounty. But if it's an application level DOS, that is usually. One of the great kind of examples of this I found is very nested JSON data can often break JSON parsers. And it usually crashes the application, not the server. But again, if you're on a pen test, obviously, if you talk to your client, they may want you to actually test for this and test the limits of, or maybe they have some kind of WAF in place that they want you to test. In a bug bounty context, not typically rewardable. API 5, Broken Function Level Authorization. It's essentially privilege escalation, both vertical and horizontal. So you want to look for this vulnerability if your target has a lot of user roles, if you can customize any kind of permissions or add permissions or assign different roles, different permission levels, if it has tenancies where you have separate organizations, so users aren't just in your application, they belong to organizations that they can then manage with their own permission levels. Any complex permission hierarchy is great for this. So how does this work? Well, you have one user, they have a post, and we said before, they can read, create, update, delete. They have all of those, 200, all nice and good. If we have another user who tries to do that, they should only be able to view. However, what if that user is an admin, not a regular user? In the case of an admin, they probably should be able to be able to read, create, update, and delete these. However, they might be doing it through a separate admin API. They're not doing it through that main API, they're doing it through something special. And again, they're an admin, they should have 200 for all of these. However, what about our plain old user? In theory, they shouldn't have access to any of this. They should all have 403s because they don't have permission, they're not an admin. But maybe one of those actually does work. Maybe one of them does return 200. And so it's essentially this idea of being able to do an admin function without being an admin. However, as we've seen with complex permission hierarchies, this can often turn into kind of a mess as you have cross-permission, cross-organization. This is a type of vulnerability that really needs a human. And for a bug bounty context, this is a great one to look for because it basically requires you to have knowledge of like how this permission hierarchy works. To test for it, create a complex permission hierarchy, create however many accounts you need to test one at every level, test that each permission is being properly enforced, similar to IDOR, go through it one at a time. You want to make sure your attacker is always your lower permission level user and your victim is the higher permission level user. If you have tenancy or organizations, always ensure that they're not just being enforced across a single organization, but multiple. So for example, if you're an admin in one organization, does that inadvertently give you admin to every organization? Generic University has some examples of these, and you can actually watch one of my other videos on Generic University to see this in action. 6, unrestricted access to sensitive business flows. It's a type of business logic error, basically. Whenever you're dealing with an API that's doing more than the typical CRUD, you want to be keeping an eye out for business logic errors because it's very easy to get wrong as somebody who makes APIs. So you can imagine here, you've got a user, and because you're a modern application, you let them use like mobile devices and desktops, and to make it easier, you have an API. Your API is then connected to OAuth, so to use social logins. Maybe you're using a payment gateway as part of your backend logic. Your database is connected to a data analytics platform. Your API is connected to cloud storage, which is connected to a third-party online store, which now connects to your payment gateway. And if you have support, they now are testing and going through the backend logic, and you've got usage essentially, downstream functionality of this can be vulnerable. You're not looking necessarily at the APIs, but at things like, is the third-party store that connects to the back end of this particular application, is that secure? Is the usage monitoring that's monitoring the database secure? Is the support functionality secure? Is the data analytics? Really good if you look for blind issues, blind SSRF, blind SQLI, blind XSS, because often you won't get visibility into these, so it can help to have something that pings back to you. This actually testing for this depends so heavily on the application and what it does. Test the functionality. Make sure the security controls it says is in place are actually in place, and make sure that any integrations aren't giving you a window in something that's vulnerable. One time I was testing an email application, and I actually used Shopify in order to trigger a blind XSS. So I was able to use a third-party service to get it onto this other client. Whether or not, it can depend whether or not they accept third-party issues, but usually third-party issues that then are like triggering on their systems, aka they just trust the output. That's the kind of thing we're thinking of here. If you want to learn more, there's tons of disclosed reports. Read them. They can be such a good resource for understanding the broad business logic, because it really can come anywhere. There are so many different ways. I really can't tell you everything about it. API 7, server-side request forgery. If you are familiar with the OWASP top 10, you will know that this has already been on there for quite a while and it's not new. SSRF on API is exactly the same on regular web apps. The only reason it super applies to APIs in particular is because often they will fetch content from other URLs. So let's think we've got a corporate network. We've got some file servers, we've got some database, we've got some other servers. Maybe we also have a cloud set up. We've got our AWS, our buckets and our keys, and we have a firewall protecting the corporate network. And in the middle of this firewall being both on the public network, also on the private network, but also public facing, we have a web server. And a user can interact with the website and therefore the web server. They can also interact with things like S3 buckets. But usually it will fetch the data itself. So you can imagine a server that maybe can grab data from an S3 bucket to load your avatar, for example. But because it's on the same network as the corporate network, it can also not just load our nice photos from our S3 bucket, but it can also fetch documents from our file server. Because fundamentally it's on both networks, it can read from both places. So that's essentially how SSRF works. You can get it to do things like internal port scanning. There are ways to expand it to SSRF. That's essentially SSRF. The idea is if you see a reference to a URL, you try and put your own URL in there, or try and access something internally if they have an SSRF sheriff. Set up a tool like Burp Collaborator if you have Pro, or Interact SH, which is free. If you see a parameter that is a URL, you're going to replace that with your Collaborator or Interact SH. You're then going to wait and see whether or not the server connects to your instance. If you connect to it, that's not a vulnerability. It's only if the server does it on your behalf. And if your target has an SSRF sheriff, you want to change that URL to be the SSRF sheriff instead. Again, it shows you can access the internal network. Again, if you want to learn more, Portswigger Web Security Academy, it really is a fantastic resource for learning a lot of vulnerabilities. It's not necessarily realistic, but it's a great way to see breadth and also have not just the labs, but the explanations as well. API 8, security misconfiguration. This covers a ton of different vulnerabilities. And because it covers a ton, you should be looking for it when you have information about how an API is being run. Maybe you know the framework or the language. Maybe you find stack traces. Maybe you're not seeing CSRF errors during testing, but you know a bit about the infrastructure. Because it really can be. It could be CSRF issues, it can be caching issues, headers, over-permissive cloud settings, TLS issues, overly permissive security controls that are done at the framework level, debug mode being switched on, failure in cross-resource origin sharing or cause settings, the intentional disabling of security features, your commit history of the code, framework-specific configuration and vulnerabilities, same-site cookies, out-of-date software. It covers a bunch of, not all of them are minor, they tend to be more minor issues. Again, this is really framework-specific, so you have to learn a few different ones for common frameworks, a few common design patterns. I recommend learning things about cause, about OAuth, and about CSRF as being like the top ones, and then you can learn everything else as you develop more as a hacker. And again, Portswigger's Web Security Academy is very good at this. It's got a very good cause section that goes over a bunch of these vulnerabilities. I really recommend it. API 9, improper inventory management. And essentially, this is like leaving old versions of APIs up, even if you fix them for a vulnerability. So maybe you leave version 1 up because you fixed it in version 2, or you leave an API endpoint that was supposed to be removed when the piece of software was deployed because it was just for debugging, whatever. If you see an API that has version numbers, you want to be checking for this. And essentially, all you're going to do really is somebody has said there's a bug in your API. The client says, we'll fix it, thank you. And even though they fix it, they still support the old API for 6 months. But the old API is connected to the same backend logic, the same database. And therefore, because it's still accessible and it's still available, the exploit hasn't really been fixed. The older version is still left up, even though it should have been decommissioned. If you see a version number in an API, always change it to an earlier version. Check that the earlier version is impacting the same data as the live version though, or even if it is not impacting the same data, that it potentially, somebody could be still using it. Test older APIs for security issues, even if you think, oh, this is like version 1, they've probably fixed everything by now, still test it. Have a look at disclosed reports for the client you're looking at and see whether or not they've actually been fixed or if they've been reintroduced, because that does sometimes happen, and I've seen that get reported. As long as the vulnerability is in the kind of end state, they'll still accept it. API 10, unsafe consumption of APIs. This is all about the fact that APIs aren't alone. They always work together with other APIs, and they can trust API output, even if they really shouldn't. So you want to be looking for this vulnerability if the API you're testing calls literally any other API. We see it a lot with ChatGPT, trusting the output. Any integrations should definitely be tested. This is very similar to API 6, unrestricted access sensitive business flows. It's just, if that's downstream, this is like upstream basically. So again, all of these providers are going to be third party. That OAuth, third party. Cloud storage, third party. Support, third party. Online store, third party. Payment gateway, third party. All of these will be using APIs to some extent. And so we want to test not just that, again, you see it very commonly, prompt injection on LLMs at the moment. Again, super API specific. You can try and make the API return some untrusted input. A great one, I think, is this Immersive Labs prompt injection to get a feel for how this can go wrong. So that is the OWASP API Top 10. I know this was like a really quick run through, but I just want to talk about some of the big changes. Honestly, if you're already familiar with API hacking, this probably wasn't all that big of a change. But like I said, I've got the full kind of blog post about my thoughts on whether or not I think this change is good down below. Also, thank you very much to our sponsor Snyk. Remember, you can check them out at snyk.co/insiderphd, and then you can have a go at actually like throwing some of your own code in there and having it resolve the vulnerabilities for you. So thank you very much, everybody, and I will see you all in the next video. Bye, everyone.